this video, we're going to talk about compounding and interest. So let's assume that we've got $2,000. We're going to put that into an account. That account is going to pay 6% at a nominal rate. So that means we're not thinking about compounding when we think about the 6%. But then we're going to compound that. We're going to compound that monthly for 5 years. So the question is, how much money will you have after 5 years? To answer this, what we want to do is we want to use the equation. Your balance is your principal times 1 plus your rate divided by n, where n is the number of times you're compounding, to the power of nt. So let's take this piece by piece, how we get values out of this. So first off, principal. That's the 2,000. So the first thing we're writing down here is the 2,000. Alright, then we've got this 1 plus the rate. Just a little bit of time on the rate over here. We want to find the rate. R is 6%, but I'm hoping you're getting used to the fact that now when we write this, that's going to be 0.06. We write it as a decimal. Okay, so that's where the rate came from. Okay, what about the n? Well, the n is how many times we compound, and the clue there is monthly. That's where we're talking about the n. So we're dividing by 12, and that's also going to appear on the outside. And finally, what we have is the number of years, so the time. So that's the 5 years right there. That's times 5. Now, I know that's a lot of different colors, but if you put that into your calculator, what you get is $2,697, and to the nearest penny, I got 70 cents. So that's how much we have. So keep in mind what we had to do here. We had to find the initial amount, the 2,000, the rate, 6%, written as a decimal, the n, which is the number of times we're compounding per year, and the t, which is the number of years. Now in part B, we're doing something a little bit different. We want to know the effective annual interest rate. To do this, we're going to take the expression that we had before, and I'm going to plug in everything except the t. So notice that I'm writing everything the same, except for the t. Now I want this to look like our typical exponential function, a times b to the t. Now the 2,000 is our a, that's fine. This big thing right here, I will put a box around it. All of this is your b. So what you want to do right now is find your calculator and compute what's inside that box, because that's going to turn into the b that we want. So this comes out to 1.06, and then to a couple more decimal places, what we get is 17. So we've just converted this complicated expression into something that looks like a times b to the t. Okay, what does that mean? Well, remember that b equals 1 plus r. Now this is a different rate r. This is where things can get a little bit confusing. But in this case, the annual rate we get is 0.0617. Convert that back to a percentage, that's 6.17%. What does this mean? Well, think about the following. You have 6%, which you're compounding monthly. That means at the end of the year, you're getting more than 6% because you're getting interest on your interest. You compound after a month, that gives you a little bit of interest, and then you earn interest on that amount. This is a way of taking that initial rate and how often it's compounded and converting it into what you get at the end of the year. At the end of the year, that type of investment will net you 6.17% interest. So that effective annual rate, I add the word effective there because it's important. That effective annual rate is what's effective given the compounding and the interest rate. So this is how you talk about compounding and interest in the context of exponential functions.